Okay, he is explained this dual nature of the particle by theoretically but not the experimentally proof. Okay, before introducing the dual nature of particle, scientists have thought that a light wave is having the wave nature and particle is having the particle nature. But in Planck's quantum theory and photoelectric effect, wave or radiation or light possessing the particle nature. According to scientists, they are having wave nature only, but here these are producing the particle nature. This is a major question to make dual nature of the particle. Okay, if a particle is having the if a wave is having the particle nature, then why don't a particle is having the wave nature? That this dual nature of the particle is explained by a de-Brogle. Okay, let us discussing about the de-Brogle hypothesis. He telling that all moving particles are having wave nature. All moving particles are having wave nature. Okay, that wave nature of high or low, which is depending on the mass of the particle. That wave nature, whether it is high or low, which is depending on the mass of the particle. Mass of the particle. Okay, he is telling that not only about the wave nature of the particle, but also explaining the wavelength of the particle. Okay, for his explanation of wavelength, he should take Planck's quantum equation and Einstein equation. What is the Planck's equation here? E equal to h nu. This is the Planck's equation. Okay, this is the Planck's equation. Here h is the Planck's constant, nu is the frequency, then nu equal to c by lambda. Okay, nu equal to c by lambda. After applying the mu, we get E equal to hc by lambda. Okay, hc by lambda. Let us take Einstein this de-Brogle equation is applicable to high mass of the particle and low mass of the particle. But high mass of containing particles are not having that much of results, but low mass of the particles like electrons, protons and neutrons, those are having good results. If the particle is with high mass, that wavelength is very negligible. But coming to the smaller particles like electron, proton and neutron, those wavelength is it is calculated, which is applicable values are coming. For high mass, it is not applicable because very minute results are coming that was not seen. Okay. Let us see case 1 with the high mass and case 2 with the low mass. Let's discuss about case 1. In case 1, he take one football. Let us assume that the football, this is the football which is having mass 1 kg. Having mass 1 kg. And also velocity this is converted into the angstroms, then we get lambda equal to 6.606 into 10 power minus 25 10 power minus 25 angstroms. Okay, this is the wavelength of the football. Okay, this is very negligible wavelength we are getting here. That's why he is telling that larger mass containing particles are negligible wavelength, having negligible wavelength. That's why he concluded that the particles are with high mass, they are negligible wavelength. They are having negligible wavelengths. Okay. Let us come to the case 2, the particles of with low mass. In case 2, he take an electron. In case 2, he take an electron. What we are observed in the case 2? In case 2, they have mentioned the mass of the electron, velocity of the electron. What is the mass of electron? Let's take small. What is the mass of electron? 9.1 into 10 power minus 31 kg. Okay. What is the velocity of the electron? 10 power 6 meter per second. 10 power 6 meter per second. Okay. Let us consider the de-Brogle equation. Wavelength equal to h by mv. This is the de-Brogle equation. From this, in this, we can mention these values. Okay. Then lambda equal to, what is the Planck's constant value? 6.606 into 10 power minus 34 by, what is the m value here? 9.1 into 10 power minus 31 into 10 power 6. Okay. This is going in 3 table, 3.0 something, and this is the 2.202. Okay. This also neglecting. Then we get 2.02 into 10 power minus 34 to the 3 into 10 power minus 25. Okay, 3 into 10 power minus 25. If we cancelling these both, we are getting 2.202 by 3 into 10 power minus 9. Okay, from this we are calculating 0.7 into 10 power minus 9. Here 1 nanometer equal to 10 power minus 9 meter per second. Then we are concluding that lambda of the electron equal to 0.7 nanometers. 0.7 nanometers. This value is visible and calculating also. This value is easy to visible and calculating also. That's why this wavelength is the considerable wavelength. Considerable wavelength. By understanding this case 1 and case 2, de-Brogle says that wavelength of, by understanding the case 1 and case 2, de-Brogle smaller mass particles are having wavelength is considerable wavelength. But coming to the larger particles, that wavelength is very negligible. That's why small particles are applicable to find the de-Brogle equation wavelength. Okay. Furtherly, this wavelength equation is equating the kinetic energy also. How? Let's see how it is. When de-Brogle equation is relating with the kinetic energy, then we telling that kinetic energy equation, kinetic energy equal to half mv square. Okay. From this equation, we are getting the v value. We are deriving the v value. Then mv. Let's place this v value in this equation, then we get lambda equal to h by m into square root of 2ke by m. Okay, let's include this m into the under root. Then lambda equal to h by square root of 2ke into m square to the m. We calculating the m terms. Then we get lambda equal to h by square root of 2 kinetic energy to the 2 kinetic energy into mass. Okay, this is a relationship explained by de-Brogle with reference to the kinetic energy. Okay, by using this kinetic energy relation, he is asking questions like, if a particle of with the same kinetic energy, the particles he mentioned are electron, proton, neutron and alpha particle. Okay, alpha particle. Mention them in a decreasing order of wavelength. Okay, let us see that question also. He is asking that the question is smaller particles of electron, proton, alpha particle and also neutron are moving with same kinetic energy, are moving with same kinetic energy. Calculate mention the decreasing order of the particles. He is asking, mention the decreasing order of the wavelength of the particles. Wavelength of the particles. Okay. What he is asking in the question? The particles of electron, proton, alpha particle and also neutron are moving with same kinetic energy. They are having same kinetic energy but differ in their wavelengths. Okay, but differ in their wavelengths. Find the decreasing order of the particles. As we know that wavelength in relation with kinetic energy, lambda equal to h by square root of 2 into kinetic energy into mass. Okay, this is the kinetic energy relationship with the wavelength of de-Brogle. From this, we find that wavelength is inversely proportional to the mass. Okay, lambda is inversely proportional to the mass. From this concept, we are arrange this order. Okay, we are arrange this order. As of discussion in the previous class, the mass of the electron equal to greater. Okay? Compared to proton, neutron is having little bit variation, but coming to the alpha particle is having vast up to 4. That's why we are writing the decreasing order of wavelengths of the particles are wavelength of electron is greater than, wavelength of proton is greater than, wavelength of neutron is greater than alpha particle. Okay, alpha particle. This is the answer we are getting with this relationship. Okay. Likewise, we are asking questions. One point you have remembered that what is lambda wavelength of the particle is inversely proportional to the mass of the particle. You just grasp that point. After that, you solve all the questions what we are asking like this. Okay. Let us explain through potential energy concept also. When a charged particle like electron is moving from rest to with the acceleration v, then we are writing kinetic energy equal to EV. Okay, here E is the charge of the electron, and V is the velocity of the electron. Okay, let's conclude this value in de-Brogle wave equation, which is related with kinetic energy. According to him, lambda equal to h by square root of 2 into kinetic energy into mass. This is equation which he give related with kinetic energy. In this, we have mentioned the EV terms. Then lambda equal to h by square root of 2 into mention this one EV into mass. Okay, this is one of the relation which is with potential difference. Okay, having charged particle moved from rest to the potential difference with acceleration v, then he give this equation. Okay, understand? By using this equation, we can calculate one question. Okay, let's see. By using this equation, we can calculate one example. An electron is accelerating from rest to the potential difference. Electron is accelerated. Acceleration is nothing but moving. Okay, electron is accelerated from rest to potential difference. that equal to lambda equal to 12